Section 6.4 starts talking about polar coordinates. I want to connect this to something that you already know, which is rectangular coordinates. We've been working with X and Y. You go left so many, you go down or up so many. And if I told you 3, 2, or in this case 2, 2, you would know exactly I need to travel 2 to the right and 2 units up to get to wherever I'm going to go. This is just like with streets and avenues in a city. You can tell me how many blocks down and how many blocks left or right I can travel to get to a certain destination. Okay? And you can even get complicated by giving multiple directions, left, right, up, down, whatever. Polar coordinates are the method, the idea is the same. We need a way to go from one place to the next, but it's not going to be in left, right, up, and down. What it's going to be is it's going to be a distance at a certain angle. For example, right? You got polar is r theta. Rectangular is x comma y. Okay, so just imagine that I'm at the what we call the pole. In terms of the coordinate plane, you're used to saying the origin, 0, 0. Well, 0, 0 on a polar graph is called a pole. All right. So if we were to say, I want you to go 5 units, well, where? Okay, you have to give me a direction. Polar coordinates are circular. Okay, so if I said, how about you travel 3 units at 45 degrees? So let's say that I'm at the pole, then I would go, if this is 0, just like the x-axis is normally 0, angles work just like the original angle measurements. If I go up 45 degrees, and I take 3 units out that way, then I just found 345. If it was rectangular, I need a way of converting it back, and we're definitely going to do that. But 345 isn't 3,3. It's close. 3,3 does have a 45-degree angle, but I traveled 3 times the square root of 2. Because the hypotenuse, it wouldn't be the same. But we'll get there later. Here we go. Shh. On the screen, shh. I don't want you to necessarily have to draw this. This is the kind of graph that you're going to get on quizzes and tests and stuff like that. But look at it. Listen to me, and I'll explain it.
Looks like the ocean thing.
It is, actually. Okay? Each of your little marks, each of the lines that travel through the pole are representative of 45-degree marks. 15-degree marks. Okay? It is, right? Hey. 15-degree intervals. So you got 15, you have 30, and then 45. So up here, you see we have the point 345, the one we just talked about. I take, basically what you're going to do, I'm starting at the origin right here. And it says, okay, turn to the 45-degree angle mark, and I want you to go in a positive 3 units. Right, so there's 1, 2, and 3 out on that 45-degree mark. And that is my coordinate point. I will give you the things to draw on. I'm not worried about you drawing them all. No. No, ma'am. How would you go up 45?
It's the same thing.
Okay, back up. If you want to think about it, that is fine. So you go over, what she's saying is, could we just go over 3 units over and then take that circle around to the 45-degree angle mark? Absolutely. It's just like X and Y. If I go to the Y first and go over to the X, I can do that. Shh. Gentlemen, stop the conversation. Okay. If you go up 45 and you go out 3, positive 3, and positive 45, just like I could have positive X's and positive Y's, I can still have negative angles and negative radii here too.
So like the negative 345, the B one, could that be 3,225?
Yes, it could. You're jumping the gun. Hold still. Okay? Yes.
Would you turn to the 45 and then take 3 steps backwards if it was negative 3?
Hold on. You're all jumping ahead of me, which is great. Let's talk about what you said. Well, let's introduce this idea first. Look over at B. if I go up to 45 degrees, so I turn to 45, but I don't have a positive 3, right? I have a negative 3. So we go backwards 3. Just like the x-axis, if I had negative x's, you wouldn't go to the right, you would go to the left. So imagine your x-axis just kind of rotates. And if it's positive, you go out this way. If it's negative, you go backwards.
This is a little bit weird.
It is. Okay? It's about to get a little bit more weird. Here's the question. Yeah. Any questions about how we got negative 3, positive 45 degrees? So ultimately what I did was I went up to the 45 degree angle mark. So that really is this line right here. That dotted line represents all points on a 45 degree angle. I can go positively out towards the 45 degrees. Or I can back up and do a negative radii. I can do as far back as I want. I could do -1, -10. But it would mean you go to 45 and then you take that step backwards to get back to those points. Okay, now hold that thought for a minute. Every polar coordinate can be represented by, at minimum, 4 ways. So I'm going to give you all the 4 for A, and then we're going to do all 4 for B. I'm going to let you do that. So look at me for a minute. 345. Now here's a clue to kind of how you organize it. You're going to have 2 points that have positive radii, 2 points with negative. You're going to have 2 with positive angles and 2 with negative angles. And it's going to be a mixture of positive and negatives. You're going to make sure you combine all the different ways you can. So let me just illustrate how I can get 2 ways with a positive 3. And so if I went up to get to 45 degrees, remember there's positive angles and there's negative angles where we can go backwards. If we took this and said, well, let's go back this direction. What angle would that be? What is it? How many quadrants did I go through? I went through, I'm in all the way around. I'm almost at 360 degrees. But I'm 45 degrees short of that. So it's negative 315. So I've got both, listen, I've got both of my positive radii. So now I have to figure out the 2 negative radii. Now this is actually quite easy. Where on my graph is going to be, what angle am I going to have to go to down here to back up to get to the first quadrant? Which quadrant are we going to be in?
Third.
In the third. In fact, right where B is where I need to get. So what angle do you go around to get to that angle? Very good. Actually, let me change that color. So at 225, I get another quadrant. Hold on, don't say it. So that would be, if I went all the way to here, and then backed up -3, backed up 3 units, I would get to A again. Okay, and what's the last one? That would be getting down to here. So that would be -135. Yeah. This is confusing to start with. It will take a little time to sink in, but part of your homework tonight's doing this stuff, so you're going to definitely have to spend a little bit of time on this. Okay? Any questions about how to find all 4 coordinates? Notice, let me show you some patterns. Listen carefully, what's the difference between 45 degrees and 225 degrees?
180.
180. What's the difference between -315 and -135? 180. So if you find both, add 180 to them and you got the other 2. Just make sure you got the right radii with them. Okay, that's a trick, or a little tricky. All right, we're running low on time, so I'm going to move on to the next part. That was the confusing part. That's the tough part. If you got that, if you're sort of there, you're kind of hazy, or you're just ignoring me. Exactly. Pay attention. You're okay. Were you? Okay, good. That's fine. Good. Good. Let's talk about, this is actually a pretty straightforward part. You actually know a lot of this already. Converting from polar points back to rectangular. You were talking about this earlier. Right, trying to say, oh, if it's that there, it's 3, 3. Not quite. Here's what we do. If I give you an r and a theta, well, guess what x is? R times cosine theta. Why? R times sine theta. We just got through talking about that. That's exactly the same idea as we had before. No big deal. I'll give you r and theta. You're just going to plug it into that formula. And what pops out is, in fact, your x's and your y coordinates for your points. Okay? On the other hand, converting from rectangular to polar was pretty much the same thing. And guess what? You already know these formulas too. If I go from xy back over to r theta, then you're looking at r equals the square root of x squared plus y squared, just like we've always have. That's magnitude. And theta is tan inverse. So here are the solutions. Oops. You are correct.
Does it get any harder than this?
Ma'am?
Does it get any harder than this?
This part, no. I mean, this is it. This is all you can do. So you're going to have 3 square root of 2 over 2. 3 square root of 2 over 2. For 3, 3, I could cheat on this one, but let's go ahead and do the formulas. R is going to be equal to the square root of 3 squared plus 3 squared, which is equal to 3 square roots of 2, square root of 18. And theta is going to be equal to the square root, I'm getting ahead of myself, tangent inverse of 3 over 3. That one's easy. Tangent of 1 is just 45 degrees. So my coordinate would be 3 square root of 2, 45. So close, but not quite. Ma'am?
We can use decimals.
Decimals are fine. Any questions on this stuff? Let me recap for just 1 second. The first thing we talked about was just the idea of what polar coordinates are. They're radius. You turn a certain radius, or you go a certain radius out from the pole. You have to have an angle of which direction to point, and you transfer that to the distance. We talked about having a point. In this case, we talked about 345. We talked about you turn to the 45-degree mark, you take out 3 radii out. I can write those in 3 different varieties. That's going to be part of your homework tonight. Remember, it's got 2 positive radius, 2 negative radius, and then you're going to have 2 positive angles and 2 negative angles. They're all usually, they have matches. Then they're 180 degrees apart, each match.
Can you buy graph paper like that?
You can. Converting to rectangular, we've been doing this for 2 days now. Okay, x equals r cosine theta, y equals r sine theta. To convert to polar, if I start with xy, how do I get to the other one? X squared plus y squared, square root, Pythagorean theorem. It's basically magnitude. To get theta, we're going to say tan inverse of y over x, just like we did with the direction with vectors. Same exact things. There's your homework. The homework is basically doing that stuff. I want to do one more thing to introduce this to you, because this is not on your homework, but I don't want you to see it for the first time tomorrow. So we got about 3 or 4 more minutes that all will take.
I like squares. Why does Gauss put it in?
I don't know. I keep erasing it. Hey, look at that.